All elementary particles belong to one of two great families, the fermions and the bosons. I dealt with bosons in another video, so this one is devoted to fermions, which were named by Paul Dirac after Enrico Fermi. Fermions include all quarks and leptons, and all composite particles made of an odd number of these, such as all baryons, like the proton and neutron, which are each made of 3 quarks, and many atoms and nuclei. A key defining feature of fermions is that they have half-odd integer spin, in other words a half, 3 halves and so on. This spin is a quantum property not related to the kind of spinning on an axis that we're familiar with in the everyday world. Having half-odd integer spin means that fermions obey the Pauli exclusion principle. As a consequence of this principle, only one fermion can occupy a particular quantum state at a given time. If multiple fermions have the same spatial probability distribution, then at least one property of each fermion, such as the spin, must be different. In a helium atom, for example, which has 2 electrons occupying the same orbital, one spins up and the other down. Because fermions obey the Pauli exclusion principle, they're subject to a type of quantum statistics known as Fermi-Dirac statistics. This is distinct from the Bose-Einstein statistics that governs the behavior of bosons. As well as their characteristic spin, fermions have another specific property. They possess conserved baryon or lepton quantum numbers. This means that in any interaction, the combined number of baryons and antibaryons, and leptons and antileptons before and after an interaction must remain the same. The standard model represents 2 types of elementary fermions, quarks and leptons, of which in total there are 24 different types. 6 quarks, up, down, strange, charm, bottom and top, 6 leptons, electron, electron neutrino, muon, muon neutrino, and tau neutrino, along with their corresponding antiparticles. As well as these elementary fermions, there are also composite fermions. These contain an odd number of fermions so that overall they have half-odd integer spin. They include baryons, such as protons and neutrons, which are composed of 3 quarks, and all atomic nuclei with an odd number of protons and neutrons. The nucleus of helium-3 with 2 protons and 1 neutron, and carbon-13 with 6 protons and 7 neutrons are composite fermions. Elementary fermions are associated with matter, whereas bosons are regarded as force-carrying particles. But the distinction between fermions and bosons becomes less clear under certain circumstances. For instance, weakly interacting fermions can also display bosonic behavior under extreme conditions. This is the case when fermions become loosely bound in pairs. This is the origin of superconductivity and the superfluidity of helium-3. In superconducting materials, electrons interact through the exchange of phonons, forming Cooper pairs, while in helium-3 Cooper pairs are formed via spin fluctuations. I'll be covering more on this topic in a future video.